Okay, so we're going to talk about how to compute area when you are working with polar coordinates. So there's actually two formulas for this, so I'm just going to show each of them to you. So you could have the area of a fan-shaped region, and so I just want you to really look at the formula. There are some different conditions on it. So you have your A and your B. There, A is the lowest, B is the largest. So the difference between B and A has to be less than 2 pi. But it's a pretty straightforward formula. We assume that r is going to be in terms of r equals some equation in terms of theta. So you can just set up the integral from a to b of 1/2 r squared d theta. And remember, this is going to be replaced with whatever this function is, so this will all be in terms of theta. So this is pretty straightforward, and kind of the idea behind this is so you can have whatever curve you want, but you have one curve. And so you are trying to find the area from here to here. So this is your lowest, this is your highest theta. And so you will end up kind of carving out this space in here. So this is the idea when you have one curve. And then if you're trying to find the area between two different curves, so some area between r sub 1 and r sub 2 will be the larger of the functions, then you'll just change the graph or change the integral from a to b 1/2 r2 squared minus r1 squared, r2 being the larger of the two functions on that interval. So again, pretty straightforward idea. And if we just want a little visual, so I can have whatever curve I want, but I'm going to have some curve kind of on top or running on the outside, and then another curve running on the inside. So I take the area of this minus the area of the smaller one, and I get the area in between. So really, this is the formula for two curves. So it's pretty straightforward with this as to what formulas you might want to use. So for instance, if I were to ask you to find the area bounded by the circle r equals 3 sine theta for theta between pi over 4 and pi over 2, well, this is one curve. And so then I can really just go ahead and use this formula here. And so I'm going to set this up. So, oops, wrong color. So from pi over 4 to pi over 2, 1/2, so where my r squared is, I'm going to replace this with 3 sine theta squared d theta. And so now here's what I have to integrate. Okay, so let's make a little space. And so this is going to turn into, so 3 squared is going to be 9, so I'll take the 9 over 2 out. And okay, so now I just need to integrate this piece here with sine squared theta d theta. So this is a classic integral. We're going to use the formula. We have to rewrite this sine squared using our half angle formula. So this is going to be 9 over 2, and then from pi over 4 to pi over 2. So I'm going to rewrite this now as 1 minus cosine of 2 theta over 2. And so then I can just integrate this. So I'm going to have 9/2. So this is going to be 1/2 theta, let's see, minus 1 over 4 sine 2 theta. And now I just need to plug in my limits of integration. So now we just have to be a little careful with this. So let's see, I'll make a little more space again. Okay, and so now we can plug everything in. So let's see, I'm going to have 9/2. So this will be pi over 4 minus 1/4 sine of, so 2 times pi over 2 will just be sine of pi. And then all of that minus, let's see, this will be pi over 8 minus 1/4 sine of, this will simplify to pi over 2. So I'm going to have 9/2 pi over 4 minus 0 minus pi over 8 plus 1/4. And okay, so let's see. So I'm going to get 9/2. Pi over 4 minus pi over 8 is just going to leave me with pi over 4 plus 1/4. So I can call this 9 pi over 8 plus 9 over 8. Okay, and so for the other integral that I have for this video, so I have, now I'm being asked to find the area inside r equals 4 and above the line r equals 2 cosecant theta. So very often when these problems are presented, at least in my class, so since we are not totally familiar with how these graphs look, these are going to be framed in such a way so that you can more easily tell what's on the outside and what's on the inside. So this is going to be whatever the top function is, so something inside here, and this one will be the bottom function. And so we're finding this area inside here and outside here. So it's giving you kind of that relationship. So, right, so anyways, so here's the formula that I need to use. So we just kind of plug everything in again. So to start by setting this up, so I've got inside, so this is going to be 1/2, so this is going to be 4 squared minus 2 cosecant theta squared d theta. Now, the tricky part about this is that I don't have my limits of integration here, right? So that's going to be the part that I have to solve for. So what we can do is we can set the two functions equal to one another. So I have 2 cosecant theta equals 4. And that's going to give me that cosecant theta equals 4 divided by 2 is 2. Okay, and cosecant, remember, can be rewritten as 1 over sine of theta. So 1 over sine of theta equals 2. And then I can flip all of this to get where does sine of theta equal 1/2. And so that's kind of the way that you can go through and compress your two functions. And so I know that there are two places where sine of theta will equal 1/2. That's going to be at theta equals pi over 6 and theta equals 5 pi over 6. So if you know your unit circle, you're good to go with that. And so then I can just fill those in. So pi over 6 and 5 pi over 6. Okay, cool. So I can clear some space. And then let's see. So I can bring the 1/2 out. So I'm left with pi over 6 to 5 pi over 6. And this will be 16 minus 4 cosecant squared theta d theta. And thankfully this one is easy enough to integrate. So I'm going to have 1/2 16 theta plus 4 cotangent theta. And now I just have to plug in my limits of integration. So I'll make a little space. Okay, and so I'm going to have, let's see, 16 times 5 divided by 6. So that's actually going to leave me with 40 pi over 3. And then plus 4. So cotangent of 5 pi over 6. So tangent is sine over cosine, so cotangent is cosine over sine. So that's going to come out to negative square root of 3 over 2 divided by 1/2. So that's just going to leave me with negative 3. And then I can subtract this off. So then let's see, this will be minus 16 pi over 6 plus 4, and this will just be positive square root of 3. And I got to remember to subtract all of that off. Okay, and so it looks like this will come out to 34 pi over 3. So if I take 40 pi over 3 minus 16 pi over 3, I'll be left with 34 pi over 3. And then, let's see, minus, let's see, this is minus and this is minus. So it looks like that'll be 8 square root of 3, and then you can distribute that 1/2 if you want. But I think we get the idea here. Okay, so that's going to bring us to the end of this video, so I'm going to leave it at that, and I'll talk to you guys in another one. Bye!